My name is Upendar, Assistant Professor, Department of Pharmaceutical Engineering, B.V. Raju Institute of Technology, Narsapur. Course name is Principles and Applications of Heat Transfer. Topic name is Heat Transfer through a Composite Plane Wall. Heat transfer through a composite plane wall, which is nothing but conduction through resistances in series. What is composite wall? If a wall is formed from the series of layers with the different materials, then it is called composite wall. Here we are taking a flat wall constructed of a series of layers with different materials. They are materials A, B and C, with different materials A, B, C. The thicknesses of each layer is BA, BB and BC. Here the thickness of first layer is BA, and the thickness of second layer is BB. Third layer thickness is BC, and average thermal conductivities of each layer. Material A average thermal conductivity is Ka. Thermal conductivity of material B is Kb. Thermal conductivity of material C is Kc. The area of the compound wall is taken as A, which is perpendicular to the heat flow. If this is the wall, the area will be taken. This is the surface area of the compound wall. At each layer is same. T1, T dash, T double dash and T2 are the temperatures at the faces of the wall. If this is the T1, T dash and T double dash, this is the T2 temperatures at the faces. T1 is greater than T dash, T1 is greater than T dash is greater than T double dash and T double dash is greater than T2. T1 is the temperature of the hot surface and T2 is the temperature of the cold side surface. T dash and T double dash are interface temperatures of the composite wall. Delta TA and delta TB and delta TC are the temperature drops at each layer. They are here. Delta TC. These are the temperature drops for each layer for material A and material B and material C. Let us take the total temperature drop for this composite wall is delta T, which is overall temperature drop. Then sum of these individual temperature drops are equal to overall temperature drop. Then what is the rate of heat transfer through this series of resistances? If you write heat flow through layer 1 means material A from the Fourier's law of equation, that is QA is equal to Ka into delta TA by BA for the first layer. Similarly, if you write the heat transfer through the second layer and third layer, QB and QC is given. Rearranging the above three equations for the QA and QB and QC, the temperature drops of each layer will get here. For the temperature drop for layer A is QA into BA by KA into A. Sum of these three temperature drops of these layers becomes this. We know that total temperature drops of each sum of the all temperature drops is equal to delta T. We know that heat transfer is occurring through the each layer. At steady state heat flow, whatever the heat is transferred through the layer 1 and that is passing through the layer B and layer C. At this steady state condition, heat transfer rate through the each layer is same and that is denoted as Q. Based on this, in the previous equation, QA is replaced with Q and similarly QB and QC are replaced with the Q. And rearranging this same equation, we will get the Q is equal to delta T by BA by KA A, which are individual resistances. From this, let us take RA and RB and RC are the thermal resistances of individual layers. Then RA is equal to BA by KA A and similarly RB is equal to RB BB by KB A, RC is equal to BC by KC A. From the above result, Q is equal to delta T divided by sum of the individual resistances that are RA plus RB plus RC. If we take capital R is the overall resistance, then capital R is equal to sum of the individual resistances RA plus RB plus RC. From the above equation, we can write Q is equal to delta T by R, which is nothing but overall temperature drop divided by overall resistance. And we can calculate the interface temperatures of each layer from this equation, that is delta T by R. That means overall temperature drop, the ratio of overall temperature drop to overall resistance is equal to individual temperature drop to individual resistance. We can express the heat transfer through layers of resistances. If there is a heat transfer in this direction and the temperatures at each point, each surface T1, T dash and T double dash and T2, resistances are considered RA, RB and RC. RA becomes BA by KA and RB is equal to BB by KB A and RC is equal to BC by KC A. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.